Stanford University.
Welcome to EE380, Spring 2009-2010. My name is Andy Freeman. The administrivia for today is that Cisco is going to host a casual, fun meet and mingle directly after the talk today in Gates 104, 5:30 to 6:30. So instead of rushing the speaker down here and finding out all the cool things that you don't get when you're in TV land, there's going to be food. What a deal. Which you also won't get if you're in TV land. Oh, well. By the way, there was a momentous announcement earlier this week. We finally admitted that there was more mobile data than mobile voice. I mean, that was inevitable, but, you know, these things happen a lot faster than we think they're going to. One of the enduring myths of academic computer science is that dumb networks won. In some very real sense, that's not true. What lost was the notion that the endpoint devices would be typed in some way that we now considered strange. Instead, we have really, really smart networks that do amazing things behind incredibly generic interfaces. Today's speaker, Guido Jouret, works at Cisco, which has been at the center of much of this, and for a brief moment in time was the most valuable company on the planet, even though it didn't move anything physical. The notion that, you know, a few hundred watts of stuff transporting information around was the most valuable thing in the world. Well, in the past we had a growing number of devices, but the bandwidth per device was, you know, reasonably well behaved, at least compared to the challenge we're facing now, video. And not only is the bandwidth growing by previous standards obscenely, but the number of devices is exploding again. And the devices are ill-behaved now because they tend to want different formats. Voice was voice, ASCII was ASCII, or EBCDIC, or whatever you liked, but it was, you know, you didn't have to transform for the device. Now that's changing. Today's talk is about how Cisco sees the opportunities and challenges posed by video and beyond, because it never stops. Okay. Guido Jouret.
Okay, thank you. Thank you very much. So I'm about to sort of give you a bit of an introduction. A lot of my talk is going to be skewed towards what I would call as enterprise video, because we really think about video in sort of three different flavors. There's consumer video, enterprise or business video, and service provider video. So much of my talk will be on the enterprise side of things, but the trend for video is worldwide. And one of the things we've been seeing is that the global trend in traffic is exploding. If you think about total traffic across all the world's IP networks, any guesses? How old is IP? Okay, well, I'll give you the answer. 74. So roughly about sort of 26 years old. So if you think about this chart, imagine it extending sort of off and to the left for another sort of 25 years. It took us about that period of time to get to 4,000 petabytes of traffic a month. That's 4 exabytes. So 1 exabyte, 1 times 10 to the 18 bytes, is equivalent to all the information in all the books and magazines ever printed. Then what's most amazing is that although it took us 25 years to get to that point, the next 2 years, 2007, it doubled, and by 2010, the forecasts are that it's going to triple. So we're seeing an explosion in bandwidth led by a number of devices, but primarily by video. And about 2 years ago, we did a survey where we said, okay, well, that's aggregate video. That's all of video. That's consumers, businesses, everything together. What about looking at it just what's happening in business? And what we found was that we did a survey for about 200 companies, and we asked them in sort of November of 2008, what percentage of traffic on your network today is video? And at the time, the estimate was about 10%. And to put that into perspective, Inside of Cisco, where we have now today 700 telepresence rooms, 2,000 digital signs, 2,000 physical security cameras used extensively, our own IT organization is telling us that the percentage of traffic due to video in our network is 65% and growing. So video today, inside of our company, is the dominant data type on the network. And we see this actually becoming a trend inside of other businesses too, because what they told us was that even though it was 10% then, by November of 2009, they thought it would double to 20%, and it would grow by 50% per year thereafter. And it's a trend that we see across pretty much every industry. Fairly small sample size. On the other hand, we have some rough groupings of industries from finance, retail, manufacturing, and education. And not surprisingly, education is in the lead when it comes to embracing video. Because we're recording sessions like this today, but also, frankly, as a knowledge industry, it's so amenable to the treatment of video. And then, frankly, as students of the YouTube generation, you're much more willing to embrace video than people of previous generations. And in fact, recently, analysts like IDC, Gartner, Forrester have all started to warm to this idea that the time for video is now. And when they polled some IT managers back in 2008 as to what they intended to deploy, 61% were ready to start embracing video conferencing. And you may have said, so what else is new, right? I mean, video conferencing has been around since, gosh, the AT&T World Fair in 1964. That is true. But, sometimes in technology, it takes a couple of iterations before things finally gel and take hold. And I would argue that in the history of technology, we try and try and try again. I personally believe that this time we're ready for the dawn of sort of pervasive video. And in addition to that, when I say video, I'm not just talking video conferencing or video collaboration. There is non-real-time video, like video on demand for e-learning. There's physical security, which is not interactive, but basically is viewed and is on 24/7. So what's happening is there's more and more of these video applications coming onto an IP network. It's also interesting because you may be wondering, why is video's time now? And it's why now for different reasons across different customer segments. For consumers, the plethora of choice, whether it's YouTube, Hulu, the rise of the internet and the ability to get pretty much any content you want, anywhere, anytime, on any device, is primarily driven by entertainment. In the case of businesses, the reasons to adopt video range from they're more and more globalized, they have extensive supply chains, offshore development in emerging markets, the need to accelerate their decision making, the need to project their best people to the remote corners of the globe. All of those reasons are driving the need to embrace video by business. And then the service providers, telcos, also play a really important role. And in part of this conversation, although all of us as consumers want cheap, really fast broadband, at the end of the day, this has to be a viable business for the people putting the cable and the fiber in the ground, so do spare a thought for them. So the service providers, what they want to do is they want to find out, how can video let me create new revenue streams? And they're really worried because, frankly, at the end of the day, they have large capital investments they have to make. And they're worried that if this commoditizes really fast, that they're not going to be able to earn a return, which means that most of us won't get fast broadband. But let's take it down to a more personal level. Why is video all that compelling and interesting for us personally? And Andy and I were just talking about, what's beyond video, and we're talking about 3D, holographics, indeed engaging more of the senses, making it even more immersive, jokingly smell-o-vision. But there's no reason to believe why we couldn't keep going in terms of enriching the video experience. In fact, internally at Cisco, we talk about trying to invent the holodeck. I mean, clearly, that's a few years out, but the idea that it's fully immersive and fully engaging is and should be our goal. The reason why video is so compelling is because we're visual creatures at heart. 64% of communication is non-verbal. That's why low latency video matters. That's why high definition video matters. We can see things when we use HD video for conferencing that we can't see on standard definition. There's what's called micro gestures, which are essentially the muscles around your eye and your face that we are actually very sensitive to, even if we don't explicitly acknowledge it. And it's a vital part of communication. And then about a third of your brain is essentially dedicated to processing of vision. So essentially nature thinks that vision is pretty important. We are visual creatures at heart. My background inside of Cisco is I started in fact in our IT department. And in the mid-90s when I joined the company, I have the sense of deja vu because what I see now happening with video reminds me so much of when, in the mid-90s, people said, hey, there's this thing called the portal. It's a browser-based system. You got to check it out. You should go and build a portal. You should put your business online. And for a while, this is something that we embraced wholeheartedly inside of Cisco. I don't know if any of you know this, but for a while in the mid-90s, we were 1/3 of global e-business. Gartner did a study and essentially discovered that our Cisco.com website was actually at the time bigger than Dell, bigger than Amazon, bigger than eBay. So we were conducting more business online than any other company. I think now we have a similar opportunity to lead with video, and the two waves are actually very instructive and very complementary. Because when it was all about the web, what we realized is that the actual browser and the web server, that wasn't really the major transformation. The transformation came when we combined this technology with a change in business models. Self-service transactions. So inside of businesses, that became self-service websites for employees. Outside, it became things like e-commerce. And of course, companies like Amazon and others are continuing to ride that wave today. But if you think and compare and contrast, most companies today have essentially milked that self-service transaction automation bandwagon for everything that it can deliver. Inside of most large companies today, if you put up your hand and say, I'd like some help, you're typically given the same answer. It's on the web, which isn't terribly useful. And there's some limitation to how much you can actually ask people to help themselves do. And so whereas the web was great for transactions, we think video is that missing link. It's great for interactions. Because whether it's for healthcare, whether it's for financial services, where you want to deliver human expertise and you can't reduce it to a self-service web form, video, we believe, is the only way to deliver human talent at scale. So let me give a couple of examples of how some of our customers are innovating with video. Procter & Gamble, household name. What is the key business process they were trying to improve with video? Well, they develop, as we all use, detergent, washing powder, all the rest. And their biggest problem is how to design products that are world ready from day one. And by that, what I mean is that, whereas here in the United States, consumers like to consume their laundry detergent in gallon-sized jugs that we can stick into our oversized SUVs and drive home, in emerging markets on bicycles or on foot, that doesn't work so well. So how do you design products that are world ready? Well, so they're customers of our telepresence system. The business process they changed was product management. So what they do now is they put all of their product managers around the world in the same video call, and they strategize on new products. How should we build the next new Tide? How do we develop the next new toothpaste? And the key business process they changed is what's called the customer focus meeting. So if you think about consumer packaged good companies, they bring customers into a room. There's a window, mirrored glass, and people stand behind the mirrored glass and they watch consumers interact with the product. What they did is they actually took the displays off of our telepresence system, just keeping the camera, and they point the cameras through this mirrored glass, which means that the product managers can essentially stay in their home countries, and in a single day, they can conduct customer focus meetings in London, New York, San Francisco, and Shanghai, and nobody gets on a plane. So it's a good example of a business process re-improved or reinvented with video. And for them, the basic ROI is in travel cost avoidance. Companies spend billions on travel. ROI is very quick, 3 months. In the world of IT, that's almost instantaneous. So this is a good example, but I think it's also just the tip of the iceberg, because think about the benefits they're going to have by designing those products that are world ready from day one. That's not measured in terms of travel cost avoidance. That's measured in terms of market share, better penetration of markets, getting it right the first time, not having to do it again. Second example is of a retailer called Cabela's. Cabela's is a large sporting goods store, mostly in the southwest of the United States. They have very large stores. Customers walk into the stores, they can't find what they need, and they walk out. They have a customer service problem. So what they decided to do was to combine video surveillance with video analytics software. And so one of the things that people haven't quite realized is that as you have higher definition video, going from standard definition to high definition to 5 megapixels and beyond, video analytics comes into its own, because with more pixels, you can turn video into information. And what they're able to do is essentially count the number of people that are in the store in real time. And one of the things they discovered was that the peak customer traffic coincided with employee lunch hour. Bad idea. Second thing they realized is that a lot of people that walk into the store and they just don't find what they need, they're lost, they walk out, so it's a missed sale. So what they do is they activate something called loiter detection. Loiter detection is essentially that the system draws a little box around the person. If you don't leave that box within 90 seconds, it sends a text message to the back of the store to somebody that can help that customer, says, customer in shoe department needs help. The third thing they did is they pointed the cameras at the checkout line, and by counting the number of people waiting in line, when the lines are too long for too long, again, text message to the manager, open up another line, because your customers are going to walk out of the store. So they did this in 24 stores, and what they discovered was that in the first year, this thing boosted their revenues by 10%, $23 million, for a $1.4 million investment. So that's a 3-week ROI. I can tell you, having been in IT for over a decade, you don't see a lot of 3-week ROI projects in IT. It's also, frankly, even better than this, because that number includes the cost of the cameras, which I would argue they already had to buy anyway. All they're really doing is just squeezing more from that initial investment by data mining video. So turning video into business information is a really promising area, and frankly, one that is just in its infancy. And this is another example of what could be done. And so this might sort of freak out some of the privacy advocates in the room, but there is this technology that today can do audience categorization. So again, as you see in most airports and shopping malls, retail stores are moving towards digital signage, displays that are showing ads. And what audience categorization is all about is it's the form of video analytics that can look at the people that are looking at the sign and put them into categories. Young, male, female, elderly. So in a store like Cabela's, they have a lot of retired people in the morning, but a lot of teenagers come in the store after school gets out in the afternoon. So what you're able to do is use audience categorization to tailor the ads on the display to reflect the demographic of the people in the audience. Our video surveillance technology, of course, is primarily used for video surveillance. Notably, we have a reference account in the White House, and they're also interested in extending that further. Here's an example of where, in fact, video technologies meets consumer video technologies. So for years, for decades, police departments, first responders have been using these large push-to-talk radios. There has been virtually no innovation in that technology for the past several decades. What you're now starting to see is police departments and first responders are saying, hey, you know what? I can buy a smartphone for a lot less money and give the people on the beat these smartphones. And so what we're able to do is, in fact, beam video directly to these smartphones. In fact, one of our products does exactly that. And what it allows people to do is treat the smartphone as a push-to-talk radio. What it does is it publishes incidents to your phone. You subscribe to the incidents you want, and then you get audio, you can see text, and you can both capture and display video on that endpoint. So the worlds of consumer video and business video are in fact converging using a lot of the same technologies. We refer to this as the consumerization of IT. This is the big deal in enterprises, and here's a good example of how that intersects with video. But video has its challenges. And when it's to consumers, they want boxes that are easy to set up, content that's easy to get to. They don't care or want to know about difference in codecs, resolutions, aspect ratios, all of that. When it comes to service providers, their biggest fear is, look, video is a huge BSA, this is a 3-letter acronym of the day, bandwidth sucking application. This is both to be sort of looked at and envied, but also to be feared, because yes, it can be very compelling, it'll draw customers, but it requires infrastructure. And then for businesses, the biggest fear that businesses have is, can I afford the bandwidth? Is there a business case for putting all this video onto my network? And will this break my network? Will this break my infrastructure? So overall, we've been thinking and working on video for quite a while inside of Cisco, and we've articulated what we call our 3-pronged strategy for video, where we're trying to enable what we call any-to-any, because today video is very siloed. Video conferencing talks to video conferencing, video surveillance talks to surveillance. These worlds of video don't talk to each other, and we want to basically free video from those constraints. We think that any video on any display, anywhere, anytime, should be achievable. We also think we want to provide end-to-end solutions, meaning from camera to glass and everything in between, because today it's hard to assemble a working system given how quickly these video technologies are still emerging. And then lastly, we don't think it's just about smart endpoints. We think that it's smart endpoints with smart networks. So therefore, it's about these systems and a platform, a better network to go with that, and services to help our customers get there. So we have a simple visual that explains our video strategy, which is this. Today, we have existing video endpoints and existing networking technology to apply to existing markets. We're taking our core routing and switching and all the communication gear, which we've been making for the last 25 years, and we're evolving them to create a better network for rich media, which we call a Medianet. And just like we went from intranets to extranets, as I've already pointed out, in the near future, when the majority of traffic on those networks will be rich media, those are going to become Medianets. That's not a trademark, it's a category. It's just like telepresence, intranet, all the rest. And we're also trying to take the video experiences into new markets. For example, sports and entertainment, or healthcare, where, for example, we're using our telepresence technology to allow remote consultation with specialists. We're doing that, for example, with Palo Alto Medical Foundation here in the Silicon Valley area, as well as with the National Health Service in Scotland and New Zealand. And also education examples where we can potentially project video for remote education. We're doing some projects in India as well as in New York. But we're also making some big bets. So we're interested in things like completely transforming how television is delivered. We're also looking at the world of video advertising. And then in the world of sort of smell-o-vision or advanced interactive experiences, what we call reinventing video collaboration and communication, we're also looking at that. So that's where we're combining sort of new technologies and new markets. Here's some of the things we've done in the last 6 months that give you a sense for momentum. Cisco as a company started in routing and switching, but of course in the last 15 years we've also gotten into markets like telephony. Today we have telephony endpoints that are all video enabled, whether it's soft phones or desktop phones. We also announced a really interesting technology which I'll touch on a little bit more later called the Intercompany Media Engine. This is the key to unlocking the Metcalfe law for video, allowing companies to call each other using video. We've also responded to the crying need inside of an enterprise for a secure video sharing portal. On the outside, we have YouTube. Most companies aren't too delighted by the idea of all their private videos getting posted to YouTube. But what's the alternative? So we've created an enterprise YouTube, which we call Show and Share, which allows enterprises to do exactly that. We also have a universal soft phone that does video called Client Services Framework. And then we've invented a new device, which is coming out this month, which in fact doesn't even have a category name. It's not a router, it's not a switch. The best description is to call it a video router, and it's the Media Experience Engine. It does media and signal conversion in real time in the network. As video flows, it changes video. And then we're adding video capabilities to our bread and butter, which is routing. So we have things like our ISR, which is the best-selling branch router in our portfolio, which has dedicated digital signal processing chips to do encoding and decoding of video, to support video surveillance and other types of applications in the future. If we look at just telepresence, so if you have, any of you are fans of 24 or CSI, you probably have seen telepresence in action. We have large units, seat up to 18 people, 6 people, 2 people, smaller units. And then with the acquisition of Tandberg, of course, this portfolio gets completed even more because we're going to have many, many more endpoints. We've also, however, been expanding not just the number of endpoints, but really trying to create new experiences. So from the military, we got a request to be able to put telepresence into Iraq, into military bases, to allow the family of servicemen and women to talk to their families back, to their partners back in Iraq. And so we tried an experiment. Satellite poses problems for video, not so much in terms of bandwidth, but in terms of latency. So as you beam signals up and down into space, your overall end-to-end delay gets longer, which can break some of the video applications. But we ran that for 2 months in conjunction with Walmart. It was a great project, very, very popular. We've also been dealing with things like bundling with healthcare applications, so the ability to combine the video signal with blood pressure, telemetry data, your pulse rate, your blood sugar level, other types of additional diagnostics to allow remote consultation. We also enable recording on telepresence, for example, the ability to record video. So that's becoming a video recording studio. And that, I think, gives you an idea on how these traditional silos or categories are breaking down. So on the one hand, when we talk about putting all of these video applications onto a network, that's sort of everything is sharing the same wire. But the second level of convergence is when these applications start to blend, when you can go from one to the other. Our digital media systems offering, so this is essentially a combination of desktop video and digital signage. This allows enterprises to essentially do advertising and e-learning and those kinds of applications. The show and share application, which I mentioned just a moment ago, this is really, really brain dead simple. You can upload a video clip, edit it, add your slides, your spreadsheets or supporting documents, send it to just your work team members, or you can send it to the entire company. It's content distribution network aware. It has full security. So this is really a YouTube for the enterprise, if you will. And when it comes to video collaboration, one of the questions that we often get asked is like, so what should I get? Should I get video conference, a video phone? Should I use my laptop? Should I use telepresence? And we think it's really a multi-dimensional question. And it's down to what experience do you want to provide? And for us, today, the best experience we can provide is telepresence. I would suggest putting sort of the Star Trek holodeck on top of that. But ultimately, the most immersive experience we can provide fills your entire field of view, feels like you're there. That's sort of the high end. The next tier, in terms of quality of experience, is something that's just very reliable, very predictable, won't be quite as immersive because the screens will be smaller, also won't be as expensive, frankly. And then the next tier is like just best effort. Look, I know that it's not always going to work, it's not going to work reliably, or it's going to be the greatest quality, but I'm a road warrior, I need to have something I can carry with me. So one dimension is sort of tiers of experience, and the other dimension is really the range of, or the number of people that you can have into this video conference or video chat, if you will. And we know that in some cases, you want lots of people. Like today, there's quite a few of you out here. Some cases, it's just you. So if you think about these two dimensions, what you get is the ability to populate that with a wide range of endpoints. There's some things that are, I think, universal across this, which is they're all moving to things like H.264. They're all moving to become high definition. Some of them are looking beyond high definition to 3D and beyond. But essentially, from high-end endpoints crossing over to video phones, to soft phones, to mobile soft clients and beyond, there are a number of potential things we can do, including probably one of the worst kept secrets inside of Cisco, our home telepresence technology, which isn't out yet, but will be later. And so therefore, this is a wide range of video endpoints that cater to these different experiences and different sizes of audiences. We also, however, recognize that a lot of people want to run video on their laptops or their mobile phones. And we don't believe in a one-size-fits-all for that. So what we have is a number of different applications. We have our WebEx client. We have our unified communicator, which is a dedicated soft phone, if you will. And then we also work with third parties because some of our partners and competitors have their own soft phones. But a lot of our customers have said, we want to work together. We want you guys to work together with these other people so that this infrastructure is seamless. And what we've done is we've said, well, these are just different skins. At the heart of this, however, is video calling, directory, presence information, instant messaging. So we've built a common sort of plug-in architecture that we call Client Services Framework, where the same plug-in powers all of our soft phones. In terms of physical security, this is an area that, frankly, when I speak to people, they go, oh, yes, very exciting. It is actually a very interesting market, sizable market. It's about $7 billion market, and it's completely turning upside down, moving towards IP at a frenetic pace. And as we've seen from the Cabela's example, it's an area that's rich for data mining. So what we do in this market is we enable things like surveillance cameras, access control, the ability to record video onto the network, and then to play back that video and integrate it with comms and digital signage. So one of the key killer applications here is to link surveillance to mobile devices so that security guards can see surveillance footage on their mobile phones, and then potentially to link it to digital signs, so if you have an emergency situation, you can tell students to evacuate buildings and things like that. But there's still a lot of problems, major challenges with video. And the major challenge overall is that video is siloed. So if you look at a large company today, you would discover that they have things like, they have video conferencing / telepresence, they have telephony, unified communication, they also have desktop streaming, which is desktop video, e-learning applications. They also have digital signage if they're a retailer, for example, or they're using it to train their employees in the back office. And they'll also typically use video surveillance. The reality is, though, if you now ask them, okay, what underlying infrastructure are you running this on? What you discover is, oh, I've got ISDN, PSTN, WAN, satellite, and coax cable. So one opportunity convergence is essentially all of these worlds are moving to IP. These are just becoming IP applications. This is why our own internal research suggests that within the next 3 years, 90% of all traffic on all the service provider networks will be video. By 2013, 90% of all traffic on service provider networks is going to be video. This is why. So we have an opportunity to converge this infrastructure, but we can do more. And this is where the smart networks come in. Because if you peel back the onion on each of those, what we would call applications, you discover that they have some common needs. They need to record video. They need to transcode video. They need to potentially connect across company boundaries and provide intercompany connectivity. And so what we're busy doing with our Medianet effort is instead of duplicating that functionality across every single silo, we're moving that intelligence into the network, where it can be shared, where it can be leveraged. The benefit of that is it really enables new applications. You can now freely share video between these endpoints. But also, consider the benefit for IT organizations who now get one infrastructure to manage, one security plan to adopt, one capacity plan to review, and they can share bandwidth and share their investments. However, video is still hard. And as my friend and colleague at Cisco, Steve Benvenuto, says, where there's mystery, there's margin. There's still a lot of mystery with video. There's a lot of major challenges that we have to overcome. What are some of those problems? Well, if today you try to stitch together various video solutions, it's clear they're not designed to work together. They're hard to use, and if there's any integration whatsoever, it's the end user that acts as the glue. You have codec challenges, aspect ratio problems, format issues, MPEG-2, MPEG-1, D1, H.264, AVC, SVC. There's so many different dialects. Screen resolutions. So people talk about the 3-screen problem, right? Laptop, mobile, and TV. I would actually submit that we're going towards more displays, not fewer, because you're looking at things like electronic pads, digital signage, my GPS system in my car. So the number of screens is proliferating, not getting fewer. And all of them have their own requirements, their own specificities that need to be catered for. It's also hard to find video. So video is an opaque data type. So unless you apply analytics to it or transcribe the text of the audio that's inside it, you can't really effectively search on video today. Video is also a big data type. It's hard to store and it's hard to send. So why have we worked on smart networks, or what we call Medianet? Essentially, there's two fundamental tensions. On the business side, so the end users, they're deploying more video devices, right? Those surveillance cameras, those digital signs, those video conferencing endpoints. Those are new endpoints coming onto the network. And more business-critical video applications. So one of the interesting trends I was noticing is I've got a daughter who's going to go to college in the next couple of years. More and more universities are asking prospective students to send their applications by video clips. My daughter, when she needs to search, she goes to YouTube, not to Google. So more and more business processes are being video enabled. On the other hand, for the IT organization, the fundamental tension there is, oh, hang on, once I've designed this infrastructure to handle video conferencing, oh my gosh, now you're going to ask me to do e-learning, then you're going to ask me to do digital signage. All of these new applications create additional complexity and potential unintended consequences and interactions on the infrastructure. Also, video is a very, very demanding technology in terms of end user experience. If I delay your email by a few milliseconds, you probably won't notice. if I start dropping video frames on you, you will notice. And it might be the difference between, oh, that was annoying, to, I have no idea what they just said. I missed that important word or sentence. Or frankly, the call could drop entirely. So video is a very demanding application type. So what are our customers saying? Well, we didn't dream up smart networks because we thought that this was a good thing to do. Our customers are telling us that they cannot deploy all of these new video applications they want to deploy unless they have a better network. In fact, some of them are even saying it more strongly by saying, I'm not deploying more of these video applications until you deliver some of these technologies that you're promising. And some of them are saying, look, we need this because that's the only way we're going to scale. That's the only way we're going to be able to roll out all these video applications our end users are asking us to deploy. So we have a strategy which is really a three-phased approach, where in the first phase, which is where we are now, we have taken a look at all the routers and switches, and one of the things we realized as we internally at Cisco ramped our own video deployments was that video doesn't just load networks, it changes networks. In fact, in some cases, it can break networks. And what we've learned is that the way in which some of the networks were designed, which is really for small packets and very intermittent transmission, is in fact the very opposite of what video often looks like, which is very big packets. And in the case of applications like surveillance or signage, it's always on. It's 24/7, constantly streaming. So that's a very different design criteria or set of operating conditions than when some of these routers and switches were designed. So right now what we're doing is basically validating design. So for a customer that wants to run lots of video applications, we can recommend the types of routers, the types of switches that they should be deploying, and how they should be architecting these networks for high availability. We're just about to announce, however, the next phase, which is what we call Medianet 2.0, where what we're trying to do is make the network plug and play for video. So just like the PC industry has moved beyond this whole business of like every peripheral you connected, you had to have a whole set of diskettes with dedicated drivers, right? That was the state of PC industry 10 to 15 years ago. Where today, your expectation is you take something home, you plug it into your laptop, it just works. We want to bring the same to networking. You plug in something to the network, it just works. But that means the network has to recognize that device and say, you're a surveillance camera. I need to put you on a separate virtual LAN. I need to make sure that you decode, that you send your video at a standard def resolution or in an HD resolution, but not to exceed 5 megabits per second because I only have this much capacity in my uplink. So that dialogue between the endpoint and network is super important. And most of these endpoints are smart endpoints. They have a range of choices in terms of transmission speeds, resolutions, and codecs. So it's really important that that dialogue happen as much as possible automagically so that we reduce the complexity for the IT people. And what we see on the horizon is what we call any-to-any, where you basically just press play. You don't have to worry about where that video is coming from, where it's being stored, the format it was encoded in. It just plays. And if necessary, we will transcode it, preposition it, make it available in the network so that you don't have to worry about where it resides or where it came from. So we're selling routers and switches today that can do that. We're also going to be embedding some of this pixie dust or Medianet technologies into our endpoints. And I'll show you just a moment what that's all about. And then we're also trying to open up new opportunities to our partners as they move forward. So what is Medianet? Let's look at where Medianet technologies actually reside because they're sprinkled throughout the endpoint portfolio as well as our routers and switches. So starting with the endpoint, we're building something that we call a Medianet service interface, which is really a collection of technologies that I'll show you in just a second that make the endpoint smart and able to talk to the network to negotiate the key services it needs. And when I say endpoint, I mean surveillance cameras, I mean laptops running webcams, I mean digital signs, I mean telepresence type technologies. All of those are endpoints. Now it turns out that we also need this to happen in the network switches that those endpoints connect into. Because for quite a while to come, we don't expect that the entire world will convert to have Medianet enabled endpoints. People have existing cameras. They have endpoints that they've chosen to buy years ago that they want to keep. So if you want to make the network smart about the endpoint, if you can't put the smarts in the endpoint, we think we can embed it in a proxy function at the Ethernet port so that we can log on to that switch and say, let me tell you what I just connected to you. That's a surveillance camera. It speaks MPEG-2. It uses standard definition video. And we also want to play, or have the routers play a new role, which is really that the routers become the guardians of the video experience. Because the routers know the topology of the network. They know what's connected to what. They know the capacity of the wide area links. They know where certain shared devices like MCUs and transcoding devices exist, where gateway devices exist. So the routers discover the availability of endpoints and shared resources and bandwidth, and they manage, they try to reconcile all these competing demands for these shared resources. And then we're also coming up with new types of appliances. I already mentioned our media routers, which is the media experience engine, but there's other new types of devices that are going to emerge, because when video is the dominant data type on a network, it changes the network. New types of devices will emerge. So what is this Medianet service interface? Well, frankly, if today you plug in an endpoint, it gets an IP address, end of story. If you embed this Medianet service interface, what you get is in fact a series of additional services, discoveries, protocols, authentication, support for multicast, things like call admission control, RSVP, bandwidth reservation, technologies like IPSLA. So this is super important. Today, if an IT organization says, great, I want to plug in a video conference in my small sales office over there in New York, the only way they know if that's going to work is to ship it there, plug it in, and try. With IPSLA, you can actually have the switch simulate the traffic of a wide variety of video endpoints, trace the packets back, and figure out where you're going to face congestion, where potentially things will break before you even start. So that's really super interesting for IT. It's also very important for in terms of dealing with troubleshooting and monitoring. So these are, for the most part, key services and technologies that already exist today. So that's going to be embedded in all the endpoints, and there's a proxy of that that will embed in the Ethernet switches as well. Oops, sorry. So one example of a new type of Medianet device that's interesting to think about is what we call an intercompany media engine. Because one of the sobering ideas is that when you think about using applications inside the enterprise for collaboration and communication, almost the only application that is able to exit through a company firewall today is email. If I call from my company to my supplier or partner, even if I'm on an IP phone, that phone call goes through the public switch telephone network, gets re-encoded into an IP phone call for my customer or partner. Almost very few collaboration applications actually seamlessly connect across company boundaries. What the intercompany media engine does is it allows you essentially to get through and use the internet to establish peer-to-peer connections that are secure and reliable for all forms of rich media. Phone calls, video chats. And what's really cool about it is that it automatically discovers how to make sure that you are who you claim to be, and that you can pass that call over the internet instead of going through the PSTN. So as this deployment, as this technology becomes popular, we think it's going to cause a Metcalfe's law effect, whereby companies are going to embrace collaboration technologies more and more across company boundaries to share video, to interact with rich media. Another type of new Medianet device is our media experience engine family, which essentially does transcoding of video, signal conversion, media conversion on the fly. Because one of the problems that you face is that if your endpoint requires media in a format that's different than the source, how do you optimize? How do you convert it? This endpoint is closed, the source is closed. How can you convert the media and the signaling to make sure you can play that rich media on that endpoint? It's also a dynamic problem. Question in the back.
Does the latency allow for interactive streaming?
Yes, so the latency, the question is, does the latency allow for interactive streaming? Yes, it does. In fact, our largest device there, the 5600, essentially does the encoding and decoding in hardware. And so typically we'll do so in basically 1 or 2 frames worth, which is almost imperceptible. And so why is this an interesting problem? And I think it goes to the heart for why you need smart networks. Consider this problem. If you want to play video on any endpoint from any source, it's a dynamic problem because there's the question of what is the format of the source, what is the speed of my link, and what is the capability of my display device. And even the speed of the link is, in fact, a constantly changing question. If you think about that in the context of a consumer device like this one, this device has 3 possible link connections: GPRS, 3G, and Wi-Fi. And even those are shared media, which means that the speed or the throughput of those connections can vary. There's no point shooting HD video straight to this device. A, the link can't handle it. Besides, the endpoint doesn't have enough pixels to display it, and the CPU is underpowered to be able to decode it. So this is an interesting dynamic problem. So what we're trying to solve for here is essentially the ability to do this in real time. Sorry, I just have to realize that I'm not charging my laptop. Okay. Yeah, and it's over here. Okay. No, still not. Okay. All right. So the interesting problem there is how do we make sure that this video is optimized and transcoded and presented in the best possible way? And it's a constantly changing problem. And as we've discussed, the range of devices that are going to come, there will be more diverse, not more homogeneous. So what is Medianet, if you think about it? For the most part, it's technologies and standards that already exist. Our intention is, in fact, to build this out of open standards as much as we possibly can. So many of you that have studied networking will recognize a lot of this alphabet soup of acronyms on the bottom. The reason why we want to do that is because we don't really want to create a closed environment. What we want to do is allow people to deploy video much more readily onto networks and have that be a seamless and painless experience. Why do we want to do this? Because we think that if we do that, by making the network plug and play for video, it provides for better experiences, more efficient use of IT and network resources, and overall, faster deployment of new video applications. So we actually have a program where we also help our customers migrate their networks. Because one of the problems that you can get into is how do you make sure that when people have an existing network, how do they move to that future state of a smarter network? So our services organization goes in, conducts audits, and helps our customers migrate their infrastructures. So to capture the video opportunity, I would say that a lot of our customers are sort of in 3 stages. There's some that are just saying, look, I'm thinking about video, but I'm not really betting the farm on it today. So they just want to buy a smarter network that's future-proofed. Some of them are saying, no, I'm starting to do video already. I've got video for my marketing efforts. I'm doing video collaboration with my employees and my far-flung operations. And they basically want to make sure that that they can have all these video applications coexist on the same infrastructure. But then we also have some that are blazing a trail and saying, no, I want to reinvent. I want to transform my business using rich media. And I think the opportunity we have is that ultimately, since video is an experiential technology, you experience video. You don't read it, you take it in. It's immersive. And if you think about technologies that generally people would ascribe this is a great experience to, the iPhone, Nintendo Wii, or I would submit even our telepresence technology, why are these great experiences? I think Alan Kay had it right when he said that basically people who are serious about software should develop their own hardware. I think that if you want to deliver great experiences, you need to control the hardware, the software, and the network connections between them. So it's not really about smart endpoints or smart networks. It's an and. And I think by co-evolving the endpoints and the networks that you can deliver truly great experiences. Thank you very much. Questions? Yes?
So for the security applications where you're trying to replace the two-way radios with maybe iPhone,
great question. So the concern is, look, when it comes to security applications, especially for first responders or police, when using consumer-grade technologies versus reserved frequencies and dedicated devices, is that a concern? Well, although on paper it looks like it would be, what's happened frequently is, in fact, people have discovered that because so many consumers are using these technologies, they end up being quite robust. And that in many cases, for example, unfortunately during 9/11, while the public switch telephone network got congested and had issues, the internet in many cases stayed up. Even though it slowed down, it was able to sort of route around some of these problems and still keep going. So more and more, I think public safety, they're actually concerned about the opposite problem, which is that they're on a technological dead end when it comes to evolving some of these technologies. And if they essentially align with consumer technology, they get cheaper technology, but I think overall they will get better performing technology as well. So while that is somewhat of a concern, I think it's ebbing. Yes, question in the back.
A lot of the excitement around Flip was that Cisco was able to drive demand for video by expanding its reach. I'm curious how Cisco thinks about software and owning or developing software to drive in the same way.
It's a great question. So for the benefit of viewers on the iTunes, so the question is about software. With the acquisition of Flip, generating a lot of excitement for video, what is Cisco's belief in software as a complement? A lot of our products are a combination of hardware and software. We just tend to deliver the software on big boxes of metal as opposed to electronically or on CDs. But we've always developed a ton of software that sits inside these devices. With the advent of something like Flip, I would say that if you've used the Flip camera itself, what you discover is, in fact, no disrespect to my colleagues there, the hardware is actually not the most exciting part. It's all about the software. It's the fact that the software is pre-embedded on the device, you stick it in, it works, you can plug it in a cyber cafe, you've got everything you need to edit and share that video. So the software is becoming really critical. If you look at a product we just announced, I think you see the crossover of that into our networking portfolio, which is just a few days ago we announced a product called Valet. And what Valet is, it's basically home networking and using that same idea of utter simplicity aided by software. So that essentially you plug in a USB key into your laptop, you answer a few questions about how you want your home network to run, you take that same USB key, stick it in the Valet router, and then into any other PC that you have at home, and that's how you set up your network. And that's a really interesting example because the software running on that little USB key can inventory your laptop, change its settings, discover what settings need to be changed, and then enforce those same settings into your router. So software is a key component of our strategy going forward. I think it's really hard to dissociate hardware from software in video because it's the yin and the yang. Okay, any other questions? Yes?
What are some of the technology holes that Cisco expects to plug by acquisitions?
Which companies would we like to buy?
Or technology?
Or technologies. I would say that I'll give a more general answer, perhaps, in part because our legal team would probably crucify me if I was too specific. But I would say that it probably doesn't disclose anything that's too confidential by saying that primarily anything that drives greater adoption of video onto enterprise and consumer and service provider networks is fair game. So I've listed a few of those typical applications today. Any others that I didn't mention but that you think that companies or consumers might want to buy are all fair. If you think about some other elements in our portfolio that you may not be familiar with, we make set-top boxes. We have, on a service provider side, just acquired a company called Starent, which is essentially a gateway to your mobile device. So we don't make handsets, we don't make mobile devices, but when you're using rich media services on your mobile phone, the odds are that that's going through a Starent device, and that's a good, interesting place in the network to potentially add value to those rich media streams. So we're also interested in things like femtocells and other things where we can offload some of that rich media traffic and put it across a broadband connection. So anything that either creates new video traffic or that helps us to manage that video traffic is interesting. And that could include, specifically in the area of consumer, anything that makes it easier for consumers to use network technologies. So that could be entertainment applications, communication applications. It could be cloud-based, on-premise, or in between. We have a rich range of deployment models. And given our coverage in terms of enterprise and consumer, sky's the limit. Hardware, software, appliances, you name it. Yes?
You mentioned fairly early on that one of the big problems is how to monetize this, and the ISP pay for this crushing bandwidth and video. YouTube and iChat, Skype conditions people that video is free, or even Hulu. Is kind of the up the bar. And how is this going to pay for the infrastructure?
That's a great question. How do we pay for the infrastructure, especially when, for a lot of consumers, the consumer experience is not exactly free because you had to buy that laptop and you may, in fact, be paying it through ads, but you don't pay it directly necessarily, or it's already paid for, I would say. So I think in the case of the consumer space, I think people will pay for simplicity. I think there's a number of technology companies that have shown that simplicity can command a premium in the market. And so I think that's one potential avenue. I also think that people will pay for convenience. And I think there's a big experiment now happening on television, whether people are going to pay for on-demand stuff or watch smaller or shorter ads, maybe more personalized ads, as a way of monetizing that. So I think for consumers, there's a number of ways. I think the biggest problem is probably for service providers, which is that as they're starting to look forward to a day when, in fact, subscription-based models don't necessarily reflect bandwidth consumption, right? So some people for $39.99 a month may consume little, others may be on there all the time, and given that it's a flat rate, all-you-can-eat model, they have to make sure that they can recoup their investments. This is a big, big quandary within the service providers. I personally believe that one of the problems is, I think, a little bit of a lack of imagination when it comes to how the different revenue streams they can tap into. A lot of the service providers are essentially producing an arms race where it's, more bits for less is kind of the basic paradigm. And I have not seen, I'd like to see, more examples of innovation in perhaps providing different additional services, tiered services, maybe even saying, look, if you're going to do a lot of Skype or a lot of interactive video, I can provide a class of service that protects that traffic versus Junior upstairs that's maybe downloading some MP3 files. And I think that's an interesting issue. It's somewhat contentious because it gets you very close to sort of the whole net neutrality debate. But I think it's a question that we need to answer, which is, in essence, although I think a lot of people like the idea of net neutrality, that all applications are equal, what if you're willing to pay for that not being the case? What if you're willing to pay for some of your interactive television experiences being more protected than others? And I think that's a debate that we've not yet had. And I think the future for service providers is to figure out ways in which they can offer more services rather than just keep plugging more bits for less. Yes?
You talked about more intelligent network,
Yes.
as well as having intelligent endpoints. Then what do you think about peer-to-peer video streaming, which requires a dumb network?
Oh, interesting you should say that. So a question, just to rephrase it, is, smart endpoints, smart networks, what about peer-to-peer, which requires a dumb network? I would restate that question. I would say that peer-to-peer currently assumes the network is dumb, but there's good examples of where you could benefit if you knew that that wasn't the case. So here's a good example. In fact, some of our service providers are looking to create ways of essentially using content distribution systems. So for example, if you're thinking about, say, cable television, and you watch a movie on demand, they are trying to push those movies to be as close to you as possible. But given the sheer number of movies that may be available, it may not make sense to try and put every single movie as close as possible to you, especially movies that are very obscure that very few people watch. So a better answer might be to keep some of those somewhere else. And what some of the service providers are looking at is to use peer-to-peer networks, peer-to-peer technology, to replicate content among their content distribution caches. But they're using a topology-aware peer-to-peer network. Because the problem with some of the peer-to-peer networking technology is they assume that the network is entirely flat, that getting that next piece of content from the remote corners of the earth is as convenient as getting it from somebody else in your local area network or somewhere closer by. So if you were topologically aware, you could make peer-to-peer work better. And I don't think it's an either or. In fact, we have extensive use of distributed hash table technology peer-to-peer inside of our content distribution system. We have something called Service Node that we use in service providers that's entirely built around that technology, but it's topologically aware. Yes?
15 years ago, there was a glut of dark fiber. What's the situation now?
That's a great question. What happened to all the dark fiber? Well, it's not so dark anymore, is the short answer. In fact, as you saw from that exploding traffic chart. Now, the interesting thing, though, is that we're getting more and more out of the fiber we had. Whereas, we were shooting one wavelength of laser beams across that only 15, 20 years ago. We're now getting, thanks to things like DWDM, up to 100 wavelengths through the same fiber. So that same piece of fiber is doing 100 times more. So and the reality is there's actually large-scale fiber deployment projects. For example, there was a big fiber link that was just laid across both the east and the west coast of Africa, which, as its connectivity winds its way through the continent, will probably drop the cost of connectivity while improving the speed of connectivity probably 100-fold in the next couple of years. So big deployments of fiber. Of course, there's projects to deploy fiber to the home or fiber to the curb, fiber to the nearby area. Those are still ongoing. There's, of course, a big project here in this country. The FCC has come down in favor of trying to encourage 100 megabits per person as sort of the birthright for bandwidth, which we would strongly support. So fiber is still a very interesting and promising area. There's countries like Singapore that are trying to deploy fiber to every single home in that country. So promising areas ahead of it. A lot of that initial fiber that was overbuilt is now happily being consumed. And we think that with the advent of video, especially as video moves, especially things like television programming, becoming more and more accessed over IP networks versus traditional cable plant, that's only going to accelerate. So the fiber is not so dark anymore. Yes?
If I'm doing back of the envelope sort of calculations, what does a video conference cost?
In terms of bandwidth or money?
Both.
Both? Well, so part of the question is... No, it's not sensitive at all. It's just that if you remember my chart where I showed sort of high-end telepresence endpoints down to a webcam, so the problem is all of those you could define as video conferencing of some form. So it's not a one-size-fits-all answer, but let me start with the bandwidth question. Typical standard definition video conferencing, so you have to realize that up until recently, most video conferencing wasn't even standard def. It was 320 by 200 is sort of the traditional resolution for video conferencing. There you're talking 256 kilobits, 384 was sort of a common range. Today, standard definition is 500, 600 kilobits. If you're thinking about high definition, 1080p, you're looking at between 3 and 5 megabits per second in bandwidth. In our telepresence system with 3 screens, that's typically around 9 to 15 megabits per second is what you're looking at in terms of bandwidth consumption. On your home network, if you're lucky, you've got a really speedy broadband connection, you might be saying, hey, that's not too bad. I can support a single screen. I have 3 megabits up or down. I can do that. Now, the first key question there is you need that to be symmetrical for video, of course. And most broadband connections are oversubscribed, which means your uplink and your downlink are not the same. And then the other question is, where are you calling to? Because even if you're getting 3 megabits a second to San Francisco, you may not get 3 megabits per second to Shanghai, to Johannesburg, or anywhere else you may choose to call. So your mileage will vary. In terms of cost, it's anything from like the cost of a webcam. Today you can pick those up fairly cheaply. Even the HD webcams that are coming will probably be in the $150, $200 range. So if you already have your laptop and that's already paid for, then the additional cost of a webcam is not so great. In terms of the high-end immersive experience, we're talking hundreds of thousands of dollars. So that's the range, from a couple of hundred to hundreds of thousands. The network costs.
Send my bits from here to Chicago.
Right.
How should I think about the cost of that?
So the cost of connectivity, again, there isn't a sort of one-size-fits-all answer, but if you think about that in terms of a typical enterprise cost, what they would pay. So the cost of the technology of choice for most enterprises is typically in the last mile a Metro Ethernet connection, which is replacing what they did before with T1 lease lines, for example. There you're talking hundreds, potentially thousands of dollars to get a couple of megabits into that remote branch office, for example. So typically that's the cost of their connection. Now they're using that not just for video, of course. All of their transaction traffic, application traffic will all go through the same link. Other questions?
Remember to announce your...
Yes, I was just getting to that. So pleased to announce that I'm happy to stay here and take any other questions or interactions as part of a meet and mingle. That's in Gates 104, starting now and going till 6:30. So there's food, so you're all welcome. Thanks.
For more, please visit us at stanford.edu.